implementing to achieve your goal of the net zero by 2050. Congratulations on the recent release of your flexibility strategy. This year's Clean Energy Ministerial comes at a crucial time, which, despite being a grim year for society and the economies around the world, but presents governments with once-in-a-lifetime opportunity to reboot economies, accelerating the transition to more resilient and cleaner energy future. This year has highlighted the importance of a robust energy, in particular electricity sector, which has kept our health, food, and communication systems running. But the power sector still accounts for 41% of energy-related emissions. To reach our long-term sustainable energy targets, we will have to substantially change the world's generation mix, expanding variable renewables and other low-carbon sources. The share of variable renewables energy needs to increase from less than 10% today to 50% and beyond by 2050. We already see this in many countries and regions of the world, such as Denmark, Ireland, Germany, and South Australia and Texas. Flexibility is becoming the backbone of modern power systems, and it is a topic that the IEA has been working on, either through the bilateral cooperation or through the CEM's Power System Flexibility Campaign for some years now. This campaign, hosted at the IEA, brings together the public and the private best practices from around the world. And we are thankful for the trust that has been put in this effort, and we will strive to continue the positive work. Power system flexibility will not come from a single source, but from a portfolio of technologies that includes grids, storage, demand responses, sector integration, and digitalization. Greater investment will be needed on grids for a smarter, more efficient, and more resilient system. And that's why we are happy to host this event, along with the International Smart Grid Action Network. Welcome, Mr. Luciano Martini. Beyond the power sector, sector coupling through electrification of end uses will become essential to tackle emissions in hard-to-abate sectors like transport, residential, and industry. It is important to identify potential synergies early on and set policy priorities. In this regard, I would like to welcome colleagues from the Electric Vehicle Initiative and the 21st Century Power Partnership, who will present the findings from the CEM's first Horizontal Accelerator. Efficient markets and digitalizations are already a cornerstone of energy security and will need to keep up with changing requirements. I would like to thank the Swedish Energy Markets Inspectorate for being a driving force in this topic, and welcome Director General Ann Badas Nielsen, who will moderate the panel. Now, finally, I would like to welcome Director General Gilberto Dialuce from Italy's Ministry of Economic Development for providing a forward-looking perspectives on the future collaboration on digitalization. Now, without further ado, I wish you all an excellent discussion and would like to hand the floor to Minister Yobet. So, Minister Yobet, the floor is yours. Thank you.
Thank you. Good morning, everyone, and good afternoon, everyone. I want to start by thanking the organizers of this event, in particular to the International Energy Agency for inviting me to share our view of the challenges of the decarbonization process and how sector integration could help to address those challenges. I would like to also thank sincerely the Kingdom of Saudi Arabia for making this meeting of CEM and MI possible despite the unprecedented situation we're going through. Chile has committed to phasing out all coal-fired generation by 2040 and to achieving carbon neutrality by 2050. These ambitions will require the large-scale development of renewable energy in Chile, as well as a firm commitment to innovation that will drive technological development in sectors that are harder to abate. Due to the current scenario, more than ever, we need to keep one eye on long-term decision-making and the other on short-term recovery. The COVID-19 pandemic has triggered the most severe recession in nearly a century, and it is causing enormous damage to people's health, employment, and well-being. Therefore, a sustainable recovery and the fight against climate change may be at risk if short-term, rapid economic measures become the low-hanging fruit. In Chile, we have put sustainability, clean energy, and climate change at the core of our recovery plan. This recovery includes, among other measures, a stimulus package for our economy that considers a public investment plan with emphasis on green infrastructure. This aspect will take advantage of our natural renewable energy resource potential to drive growth and occupation within the country. There are currently more than $22 billion in the pipeline of renewable projects that have been approved or are already under construction throughout the country. There are primarily solar and wind energy projects. However, we need to tackle this crisis with a forward-looking approach and deal with the main challenges to rapidly increase renewable integration and extend this low-carbon approach not only to the electric system, but to the entire economy. In that sense, one of the main challenges will be how to manage a new paradigm of power systems with a higher share of variable renewable energy, decentralized resources, new technologies like storage, and new integration solutions for other systems through Power-to-X and electromobility, among others. We're currently working on different paths to address these issues. On one hand, to be able to manage a higher share of variable resources, as has been made clear by different countries' experiences, we need to develop a more flexible power system. In the case of Chile, we are still in a phase where our current installed capacity of approximately 25,000 megawatt can deal with the variability and uncertainty of these kinds of resources. But it is clear that we will soon need to adapt our system to a different and more sustainable model. To accomplish this, we have just published a flexibility strategy which is a roadmap of regulatory and market improvements to enable and foster a flexible power system. The support of the International Energy Agency has been key for the development of this strategy, which is based on three pillars. The first one concerns the market price signals that we need to improve to promote new investments in flexibility while remaining technologically neutral. The second is related with the regulatory framework to enable the penetration of new technologies such as storage, for example. And the third one regards the operational improvements to completely harness the flexibility system. We expect, with the execution of this roadmap, to set a comprehensive regulatory framework for a secure, efficient, and sustainable power system. One of the main opportunities for decarbonization is the integration of the power system into other sectors. And one of the silent giants in that sense, we think, is green hydrogen. We have an enormous opportunity to extract the full potential of an element that is, as we know, by far the most abundant in the entire universe. Given the scale of the Chilean renewable energy potential, we are currently developing an ambitious national strategy to establish Chile as one of the leading producers and exporters of green hydrogen worldwide. High solar irradiance in the Atacama Desert to the north and the extraordinary wind resources in Patagonia to the south will result in very low cost of production. Indeed, last year, the International Energy Agency forecasted that our green hydrogen production cost could fall below $1.6 per kilogram by 2030. Green hydrogen will play an essential role in our domestic efforts to decarbonize, accounting for around a quarter of our emissions reductions, and will also allow us to harvest and transform our natural resources to export them to the world, helping other countries to achieve their own carbon neutrality targets. There is no doubt that decarbonization is a complex problem. And like one journalist once said, for every complex problem, there is an answer that it's clear, simple, and wrong. That's the main reason why we need to keep meeting and sharing our experience and ideas, to learn from each other and cooperate globally to raise ambition and achieve a sustainable future for us and, most of all, for the generations to come. We are honored to be part of this community whose aspiration is to lead the change towards a cleaner and more sustainable energy sector. Global problems need global solutions, and that's why we're working untiringly to open the way and be considered as an example to follow for other countries that share our concern on climate change and are also pursuing the crucial path of decarbonization. Thank you so much.
Hello, everyone. I believe we couldn't have a better start for our event. I thank you very much, the IEA and the Honorable Minister of Energy of Chile. And my name is Luciano Martini. I'm with RSC in Italy, and as a chair of ISGAN and co-organizer of this event, I would like to thank all of you for joining it. In particular, I would like to thank the CEM 11 organizer and the CEM Secretariat for providing us with this great opportunity to report on the CEM Horizontal Accelerator on electric vehicle power system integration. We will show the activity and also showcase its initial achievements. Just a short reminder to all of us, we have a very rich agenda today with many high-level speakers and panelists, and we would like to ask you all to please stick with a lot of time in order to not overlap with the following event. In the next few minutes, Enrique from the Power System Flexibility Campaign and I, on behalf of ISGAN, we will be sharing with you our common view of the importance of collaborating at international level, especially when addressing complex challenges that are often associated to the ongoing energy system transformation and that require different expertise and the active engagement of many stakeholders. We will start providing you with a very short introduction to ISGAN and to the PSF, and also to our strategy for establishing a fruitful and effective collaboration as a first result of the Horizontal Accelerator, of course. And we really will focus on EV integration to clearly show the importance and the power and the need for multilateral collaboration. So next slide, please. Just a few words about ISGAN. ISGAN is the short name for the International Smart Grid Action Network. It's an initiative of the Clean Energy Ministerial and was established at CEM 2 in Abu Dhabi. Moreover, ISGAN is also an International Energy Agency Technology Collaboration Program and is the TCP on smart grids. ISGAN 26 contracting parties span the globe and include the most major developed and emerging economies. And additional countries have already expressed a strong interest in joining ISGAN, and we have a very good news in this respect. Operating as both a CEM initiative and IEA TCP, ISGAN is an international strategic platform to support high-level government attention and action for the accelerated development and deployment of smarter, cleaner, and more flexible electricity systems around the world. Next slide, please. ISGAN activities organized around 8 annexes, and they are standing working groups addressing specific topics in smart grid domain. As you can see, there are annexes that are topic related, some other that are more related to a platform for communicating our results to policymakers and the main stakeholders. And in particular, I would like to mention that the activity of ISGAN is addressing smart grid aspects where governments have regulatory authority, expertise, and convening power, focusing on 5 main areas: policy and regulation, finance and business models, technology system development, workforce skills and knowledge, and also user and consumer engagement. You see on the right-hand side of this slide that some of the key findings of ISGAN and recent achievement include the releasing of policy briefs, technical reports, position paper, as well as the organization of webinars and international workshops involving government representatives, key international organizations, as well as experts from both the public and the private sectors. So I think we are working in that direction, and that is why we would like to team up and join forces with PSF and other initiatives of CEM in order to really achieve results in a short time in a very effective way. Thank you. I think now I would like to ask Enrique to present PSF and our strategy for future strong collaboration. Please, Enrique, the floor is yours. I think you are muted.
Thank you very much. Yes, so thank you for the great introduction, and also to the organizers and to the Minister of Chile for joining us today. I think you frame it quite well. You know, there's a lot of synergies, and I think this year some collaborative initiatives have been very good to kind of show what we can do together, advising our member countries and also member organizations. Similar to the introduction you got from ISGAN, I'm going to just give you a quick introduction to what we do at the Power System Flexibility Campaign, which has been running for 2 years now. And I think the main strength that we have is based on a public sector and private sector membership. We have the support for co-leads for China, Denmark, Germany, and Sweden, and most recently India, who has joined as well as a co-lead. And we count with up to, well, now 11 members, with the UK joining this year. What we do, of course, is connecting, building this link between what are the best practices internationally, both from the private sector and from the public sector, and seeing ideas how these can be replicated in other countries, or how similar questions that get addressed from a policy perspective. As you may know from the way that CEM work streams work, is that campaigns usually have a shorter time span and usually address topics that concern more with immediate policy implementation. So really, we really target this policy visibility, where it's kind of actions that can be implemented within a year or 2 3 year span. Over the last year, we've organized a series of events, primarily driven bilaterally with our partner countries. So, for example, we've done a couple of events with Chile, with Brazil. We have the yearly PSF workshop, and we also organize bilateral webinars now with the new conditions. A lot with, for example, other partners like ISGAN and ISGAN, and now with the Horizontal Accelerator. So far we've done a second phase, and now we're going to a third phase. We're planning to also work much more horizontally with the other initiatives. And I want to just tell you now, if we can go to the next slide, a bit more about what we learned this year and where we think, the key learnings are. So one change from the previous year was that in the previous iterations of the campaign, we focused much more on, what could the flexibility resources do for the system. So, for example, what was the role of storage, the role of flexible thermal power plants, the role of demand response, or distributed battery storage, EVs. And this year we shifted the focus much more on what are the conditions that enable this. So, like what we say, as a shift from hardware to software, and really focusing on institutional context. We have 3 building blocks, which are markets for decentralized flexibility, digitalization, and sector coupling. And this kind of, brought together like a number of more, I would say, strategic learnings, particularly, for example, in the area of markets. It's not so much about creating specific markets for flexibility, but making sure that the markets that we have actually improve and work better to make the most of flexibility that is in the system. And once you've done that, address specific flexibility concerns that may arise locally or distribution level, but we're seeing increasingly so. And for example, with measures like Chile's flexibility strategy, it's very clear that it's possible to identify these needs as the system changes. The other thing we've seen, particularly with distributed resources, is that it's important to link the wholesale part of the power system, the bulk power system, with the price signals that the end consumers see and the end users see. So this requires a lot of regulatory innovation, retail reform, but also enabling access to new business models and kind of harmonizing the levels between the transmission and distribution. We've seen the need for clear digitalization strategies, for example, addressing governance, data sharing agreements. The reliability gets embedded in new digitalization approaches. And I think one thing that really comes across in the activities that we have, particularly in this event, is the need to go beyond specific sectoral silos in policymaking and really consider, for example, in this year, transport and power sector. But we plan to go more into, for example, links with sector coupling with hydrogen or with electrified heating. And this really, and from the policymakers' perspective, goes beyond the typical remit that they're looking at and requires actually being more creative and communicative. And I think as we move forward to having more complex sectors, of course, it's a question of how you build interoperability and standards in joint planning to really ensure that you have a reliable power system, which is, of course, we've learned this year more than ever, that is very, very crucial. Now, going into the next slide, what do we plan to do in the next year? I think as Luciano already mentioned, we plan to leverage the key strengths and shared synergies between ISGAN and PSF, both having different approaches to the way we bring about innovation and policy discussion, and really apply it to specific policies in specific countries. And there's two ways in which we're going to do this. One is, and I'm very happy for the invitation from Luciano to this Mission Innovation IC1 project, and also the IEA Italy project on smarter digital power infrastructure. If you can switch to the next slide, just to give you an idea of what we plan to do in the next year from the International Energy Agency perspective and through the different CEM network, this project is going to run from 2020-23. We're going to be focusing on policymakers in emerging countries, basically policy, regulation, technology, investment, and a series of looking at tools and methods for evaluation, policy guidance, webinars, roundtables, and really kind of building the knowledge that has been already accumulated through years of ISGAN and PSF experience into kind of applicable and real life policy recommendations for emerging economies that are stepping up the ambition and transition. And that will be all from my side. I'd like to thank you all for being here and yield the floor back to Luciano.
Hi. Thank you, Enrique. Thank you for clearly presenting our strategy. I just want to confirm publicly our strong commitment to collaborate with PSF and also to align and coordinate with other key initiatives around the world, as you mentioned, Mission Innovation and the IEA Italy's Market Initiative on Smarter Digital Power Infrastructure. Okay, thank you. Now we move to the next session and we come to the launching of the Horizontal Accelerator report. Magnus Olofsson, director of the Swedish Energy Institute and a pillar of the ISGAN, and Matteo Muratori, senior engineer at NREL in the US, will share the duty to make this presentation. So Magnus, the floor is yours. Please.
Okay. Okay. Thank you, Luciano. The Clean Energy Ministerial Horizontal Accelerator for Power System Integration of Electric Vehicle EV Infrastructure is an innovative new mechanism strengthening the collaboration and capitalization on the synergies between four CEM work streams. This particular accelerator is an important step towards developing a cross-sectoral and holistic approach to power system integration. And thanks for adding the presentation. In April, earlier this year, in the spring, the accelerator gathered some 70 international experts from 17 countries across 4 continents for a 2-day interactive workshop on the theme, Electric Vehicle and Power Systems Nexus. How to support large-scale adoption and effective integration. The COVID-19 called for arranging a virtual workshop to enable interaction and knowledge exchange between experts ahead of, during, and after the workshop, as well as transparent project documentation of results. A digital open innovation platform was set up for use by our project participants. Yes, next slide, thanks. The Horizontal Accelerator represents a concerted effort to unify existing CEM work streams to produce coherent analysis, conclusion, and advice. And this focused and multidisciplinary approach to EVs, electric vehicles, offers new insights into power system integration and sector coupling, guiding development of a modern and integrated energy system of the future. The insights from the workshop and complementary project activities have been analyzed by experts from the collaborating CEM work streams involving ISGAN, International Smart Grid Action Network, 21st Century Power Partnership, the Electric Vehicle Initiative, and the Power System Flexibility Campaign. So those are the 4 work streams. Finally, lead governments of the 4 work streams have been very supportive, and the project has received funding also from the Nordic Council of Ministers. So finally, now it's time to present the results, the findings in the report that is the outcome of this Horizontal Accelerator. So therefore I now give the word to my colleague, Dr. Matteo Moratori from National Renewable Energy Laboratory, NREL, in the US, representing 21st Century Power Partnership. And you will summarize the main findings in our project report. So please, Matteo.
Thank you very much, Magnus. And can you please advance to the next slide? So I wanted to thank the Swedish Energy Institute and all 4 work stream of CEM. And in particular, I wanted to thank all the participants to our virtual workshop in April for sharing insights with us and also for providing comments on this report. It's an honor for me to be here today. What I'm going to do over the next 5 to 7 minutes is to give you a brief summary, a brief overview of the main findings that can be found in this report. Just as a note, the report is publicly available. I'm going to share a link with you at the end, so I encourage everyone to download the report. And please reach out to us if you have comments or if you have feedback on it. Can you please advance to the next slide? Vehicle electrification is a building block. And if you could please move to the next slide. Vehicle electrification is a critical building block in the ongoing energy transition. As we have heard from Enrique and Luciano and the Chilean Minister of Energy earlier, transportation is an important sector. It accounts for 1/4 of the entire energy sector greenhouse gas emissions. And electrification offers a pathway to decarbonize the transportation sector and move towards a more sustainable solution. This pathway, of course, is going to involve more synergies and more integration between transportation and the power system. Transport today rely primarily on oil, on petroleum and its supply chain. And this transition towards the electrification is really opening up for new synergies and new opportunities for sector integration between transport and power system, which is really the focus of this report, trying to explore a little bit this nexus between the electric vehicle and the power sector. Before diving more into these synergies, I think it's important to note that while vehicle electrification is a building block of broader electrification trends that involve other sectors and involve deep transformation on the power system side, on the mobility side, electrification is also one of numerous trends that are evolving, triggered by digitalization and by new technologies. We have new mobility solutions. Think about micro-mobility in our big cities. Think about mobility as a service that is becoming more predominant, and behavioral changes like telework and e-commerce that are all playing a role in transforming mobility. So there are moving parts both on the power system side and on the transportation side that are quite complex and are acting upon one another. If you can move to the next slide, please. It's important to understand that to study and to better understand and to exploit the synergies in this complex puzzle that is unraveling over time, a multi-stakeholder process is absolutely necessary. When we focus about the electric vehicle and power system integration, of course, we have the stakeholders on the mobility side, the automakers, the mobility stakeholders, as well as on the power system side. But it's important to also remember urban planning and now other sectors that historically have not necessarily been too intertwined with one another are starting to engage in this transformation. And so bringing at the same table all these different stakeholders is a fundamental aspect to maximize the benefit of vehicle electrification. A couple of key points in this multi-stakeholder approach that came up during our event in April was the need to provide users, like electric vehicle users, with relevant and high quality information about what charging options exist and what are the associated costs, as well as the need for open protocols and international standards. So ensuring compatibility of charging infrastructure for EV across broad regions is really a key aspect for the success of this transition. If you can move to the next slide, please. As I said at the beginning, mobility is undergoing profound transformation, and the system that we're used to today to move both people's passengers as well as freight is rapidly changing. When thinking about electrification, one important aspect is to really understand the heterogeneity in transportation and how different systems and different services have different needs. And so when designing effective electrification strategies, it's really important to keep this diversity in mind and understand what are the needs of the different applications that we're trying to tackle. We're going to talk a little bit more about this in the following slide, but flexibility in EV charging is a great opportunity to exploit the synergies between transportation and the power system. We have heard about this from previous talks. You know, flexible demand is really complementing well the transformation in the power system and can help and support decarbonization. But when it comes to electric vehicle, I think it's important to always remember that flexibility is really important and can be extremely valuable. But it is secondary to mobility needs. So fundamentally, electric vehicles are meant to provide mobility needs, and flexibility can come as a sort of added value. But it's important to remember that we need to be secondary to what the mobility requirements are. It's also important to design effective incentives and implement them to compensate users for providing this flexibility, which is a key point for enabling a successful integration of electric vehicles in the power system. If you can move to the next slide, please. Well, talking about electric vehicle and power system integration wouldn't be possible without talking about charging infrastructure. Charging infrastructure is really the connecting tissue between the mobility systems and the power systems. And expanding the charging network is a fundamental requirement to support electric vehicle adoption. This spans a lot of different charging solutions, from home charging to workplace charging to publicly accessible charging, including fast charging. Again, going back to my previous comment, thinking about all the different needs for the mobility system, is important to provide a charging solution that are effective for all these different applications, including commercial vehicles that I haven't mentioned too much today. It's also important to understand that there are different pathways and different ways that the infrastructure network can evolve or co-evolve with vehicles over time. And this influences both the mobility options that are available to consumers. So think about a charging network at high power that enable long distance travel, for example, without which vehicles cannot travel a long distance. And think also about the ability of electric vehicles to provide grid support. A vehicle can act as a support to the grid only when it's plugged in. And so I think it's clear that for vehicles to provide grid support, they need to be connected, and this requires a network of charging stations. So infrastructure is really a central point of this transition. If you move to the next slide. Now, diving a little bit more about the practical impact of electric vehicle on the power system, I think it's clear that when we think about vehicle electrification, this introduces new electricity demand. And so there are a lot of opportunities that comes with serving this new demand, this market expansion for the power system. A lot of works have looked at how electric vehicles might impact the planning and the operation of the power system. And there is a lot of consensus in the literature that the impact on the bulk power system, so the generation and the transmission of electricity, is somewhat limited, while the impact at the local level, our distribution network, our distribution system, is likely to vary greatly. And how EVs are going to interact with those systems is really going to depend on where and when vehicles are charged. Both for the bulk power system and distribution system, however, this charging flexibility really creates a lot of opportunities to support the power system. And the two systems can really lead to more efficient operation, and not just cheaper electricity for the electric vehicle users if they provide this flexibility, but cheaper electricity for everyone, as the system is operated in a more efficient way for all users. Again, repeating 2 points, two key aspects to enable this flexibility is the availability of strategically located charging infrastructure and the design and implementation of effective incentive programs to compensate users for providing this flexibility. So to conclude, the successful integration of EVs will require a diverse array of technological solutions, a closer collaboration among different stakeholders, including equitable cost sharing between all these different stakeholders, and potentially changes to regulation and market design to enable exploiting the synergies between electric vehicle and power systems. So if we transition to the next slide, I want to leave you with a link to the report that we recently published. It's available on the Clean Energy Ministerial website. And again, I encourage everyone to download the report and feel free to reach out if you have questions or comments. And thank you very much for tuning in with us today. I return the line to you, Luciano.
Thank you, Magnus. Thank you, Matteo, for your contribution, and more than that, for your strong personal support to the initial activity and related outcomes of the Horizontal Accelerator on electric vehicle integration. The releasing of a first report, of course, is an important milestone for us, but just represent the first step in our collaboration, and we would like to rely on you also for the next steps and the next activity. So I think we can close this session. We are nearly on time, and now I would like to hand it over to Anne Vadas from the Director General for Swedish Energy Market Inspectorate to moderate what I believe is going to be a very interesting high-level fireside chat. Anne, the floor is yours, and we will be working under your guidance. Thank you.
Thank you very much, and good afternoon to you, everybody. I will moderate this high-level fireside chat, and I think we will focus on market design and digitalization, how that can utilize the shift that we are ahead of us. Historically, power systems and their market design has been developed for production to meet consumption. Not always an easy task, but what we have ahead of us is much tougher. To lower our carbon footprint, our energy system must transform fundamentally. Our power systems must, for example, cope with large amounts of variable renewable production. And in order to do so, flexible resources are needed. Even though flexible hydropower can help, Sweden is a hydropower system, but we need other flexible sources as well. For example, flexible consumption. Another important flexible resource is sector integration, and this is something that is being discussed more and more. And by converting electricity to another energy carrier, the energy can be stored and used in an industry or for transportation when the service is needed. Sector integration will, however, require a different mindset, both among all actors. And we also have to have a clear focus on the possibilities that integration can offer. In addition, a wide range of technologies, and some which are still at an early stage of development, will be needed. But I don't think that technology is the biggest challenge. In order for investing in research and development, the market value of new products and services must be large enough to make the risk worthwhile. And this is often a function of market rules and incentives established by legislation. And here governments need to develop enabling policies, but also regulators. We as regulators, we have a critical role to play in developing rules and methodologies that can balance several interests. For example, balance the interests of consumers versus regulated monopolies. And also in the future, we also have to balance those of new entrants that are functioning in a competitive environment. Apart from avoiding either over-regulation or under-regulation, regulators also need to monitor market developments. But I also think the market itself is a key facilitator, and this cannot be underestimated. Therefore, any measures that can improve market functioning and that can remove barrier to entry or lessen the impacts of market failures or distortions should be taken first. Getting prices right and making sure that price signals reach all actors, allowing them to make informed decisions, are also very, very critical building blocks of any improved market design. During this part of the seminar, we will hear from different perspectives on how innovation in market design and digitalization can unlock modern technologies for power system. And I would therefore like to turn to our distinguished panels for some short interventions. The question to you in the panel is what the policy, regulation or market reform priorities should be to accelerate power system transformation. And here I would like to start with Mr. Livio Gallo from Enel. Livio, please, the floor is yours. You are representing an energy company.
Thank you, Anne. Good afternoon, everyone. Thank you very much for the invitation. I'm very pleased to take part of this important event on behalf of the Enel Group. Electric energy systems around the world are experiencing great challenges, as we heard from the previous presentations, such as a rapid increase of production from renewable resources, an acceleration of the electrification of the energy demand, a massive application of digital solutions to manage, on one side, demand response, on the other side, also energy storage solution. This evolving scenario requires major investments in the grids, in the electrical grids. As we know, the current trends show also that from 2030 on, small urban centers, medium urban centers will converge into very large cities, the so-called mega cities. And in this respect, the cooperation of all the energy operators will be necessary for providing services able to improve the quality of life standard of the citizens, and specifically, the DCOs have to evolve fast from a mere electricity distribution providers to what we think to be a neutral service enablers, with two main sustainable benefits. From one side, easier access to services for customers, of course, and environmental and decarbonization benefits. This new energy paradigm, we think as distributors, requires an evolution of the conventional role of the distribution into a more active role through a real-time exchange of data, and we as Enel in many countries adopting this solution, this idea, investing in cutting-edge solution, enhancing the digitalization of the grid. Now let me present very briefly some digital projects, some digital solutions that we are implementing worldwide in all the countries where we are in. The first project I would like to mention is called Urban Futurability. Urban Futurability aims to transform the power grid of a urban district in São Paulo, this is called Vila Olympia, into a platform for stakeholders that will become active players in the designing of a brighter future for urban living. A network digital twin, which is a digital solution which replicates the local electrical grid from the individual physical elements into most complex operational dynamics, into a digital model, including network maps, images, 3D models, real-time grid asset status. And this solution allows and will allow a very advanced network automation, a better exploitation of a distributed generation, enhancing, of course, the grid resilience and also the quality of service. It is going to be a co-design with local stakeholders, the local communities, going towards the urbanization and electrification of the smart cities. A second important project is the smart metering system. We have now up and running worldwide more than 40 million smart meters, exactly 43 million smart meters. And this is a key driver for our network digitalization, which allow us as DSOs to have all customers connected with smart sensors to the network, even at the low voltage level. A smart system, a smart metering system, guarantees operational cost reduction deriving from the remote activities, which include readings, remote readings, cut and recognition, contrast switching, power increase, power decrease, everything performed for remote. A better logistics, and of course, very much less back office operation. Moreover, the smart metering enhances the overall system efficiency with benefits for all stakeholders, with several functionalities. For example, collection and management of great amount of data, enabling advanced data mining, artificial intelligence systems, very quick outage detection, and of course, fast service restoration, real-time energy balance at a low voltage level, low voltage substation level, real-time customer awareness regarding consumption and production. At the end, the detection of meter tampering, allowing an easily detection of consumption anomalies. Our experience says that in several countries where regulations are enabling the DSO to act as meter operator, can determine fast benefits thanks to this optimal management and balancing of the electrical grid. We experience that a suitable regulation, as you previously mentioned, Anne, is very important. And this framework can encourage investment of the electrical grid and also expands the range of services that can be offered to the customers. We think distributors need to reinforce the electrical infrastructure for the integration of charging stations, was previously mentioned, storages, increased resourcing capacity, and to provide a wide ranges of new services like flexibility on the network.
Sorry to intervene here, but we are on a tight time schedule, and you are talking, of course, about the role of the TSO and what digitalization can do. Very, very interesting.
And I'm just ending up saying that the key word for the future, I think, will be flexibility for the energy transition. Thank you very much.
Thank you very much. Thank you for your perspectives. Now we will move to Mr. Doug Arendt from NREL, and he will give maybe the perspective of a researcher. So please, Doug, the floor is yours.
Yeah, thanks, Anne. Can you hear me okay? Good. Thank you to the CEM Secretariat, to all the collaborating initiatives on this one. Let me offer just two relatively quick responses from the view of the National Renewable Energy Lab as we look at innovations in technologies, in systems, in controls, and frankly in market designs and approaches to unleash this cross-sector coupling flexibility set of options. The first is that, as been mentioned, flexibility services are absolutely key to the evolution of the energy system as it goes forward, increasing amounts of renewables, but also to recognize that there are flexible services available from every asset. And I think, as you mentioned, this includes heat, hydrogen or other chemical production, water, and in particular, relative to the launch of this Horizontal Accelerator, transportation and mobility as it becomes increasingly electrified. Services that enable this include everything from up and down ramping services to other ancillary services, to allowing distributed resources to participate in wholesale markets, a whole plethora of options there. Interestingly, from our perspective, we are able to create tools that represent millions, tens of millions of interconnected devices, be them buildings, distributed energy resources, grid assets, electric vehicles, vehicle charging stations, and are able to provide model-based insights to policymakers to help them decide which policy framework or which policies could be beneficial in their jurisdiction. Interestingly, as you also mentioned, regulation and regulated entities being around the world, there are innovations in regulatory approaches, including performance-based regulations, which have turned out to be very effective. And there's a plethora of work that we've published with colleagues around the world on performance-based regulation that could be of high use to ministers and to their staff around the world. Lastly, if I could, just let me mention digitization, which you also mentioned. Here, this enables both macro and micro innovation in services and in controls, as has just been mentioned. From our perspective, we are now working on a whole paradigm of distributed autonomous energy system control, which allows both fast cloud-enabled control and optimization, but also provision of services, provision of business services, cyber-secure solutions. And these innovations will increase the ability to unleash flexibility throughout the whole system, including distributed resources, connected vehicles, and other industrial processes and grid management. So the forefront, I would say, of technology solutions, innovation solutions in combination with market design or regulatory approaches continues to evolve. And there's a rich landscape for lessons to be shared among not only among researchers, but really among stakeholders to accelerate these innovations or the adoption of these innovations around the world. And we welcome that opportunity for collaboration. So back to you. Thank you.
Thanks a lot, Doug. You didn't say the word, but I hear sandboxes here. Some testing in some safe environment. That's very interesting, of course. And how regulation can function, and if we can be innovative also in the sort of when we regulate. Okay, we are now going to hear a new perspective. We will hear Mr. Gerald Salge, who is with Hitachi ABB Power Grid, so a producer actually of not only old copper, I guess, but also on all kinds of smart solutions. So over to you, Gerald.
Thank you very much. Let me try to complement the very good comments and input from my colleagues here already now from a manufacturer perspective. We already heard about the keyword is really the flexibility. And when the other thing is the electricity system is in the center really of the activities. So it needs to interact in a flexible way than with other systems. So when we are talking flexibility, that means we need to really look across the total value chain from the supply, the transmission, distribution to the demand, and then create there as much as possible flexibility. Now, innovation, of course, plays the key role in that because these are solutions which are only partly existing today. And I'm talking here from an electricity system flexibility then when it comes to the demand response, and a lot of examples were already given. I'm talking about the renewable integration and connected to storage capacities. But one specific example I want to highlight here is when we are talking interconnection of systems and subsystems in the electricity grid. And that is what I mean here is, and it was already mentioned, that we have to invest more in the distribution grid, but obviously also into the transmission grid, because we need this interconnection of the system in mixed AC-DC systems on all the levels. We need to increase automation towards higher degrees of autonomy in those systems. Now, as a boundary condition, we also have to keep in mind that we have in many countries, in many regions, a very high level of reliability, of power quality and resilience. And we should not compromise on that. More the other way around, we need to do all these changes by keeping it and improving it in those areas where there is still a good improvement potential. We need to have, and it was mentioned and touched, this sector flexibility. Now, and that is something, again, which needs to be there in the generation, it needs to be in the distribution and transmission part, and it needs to be on the demand side. We have heard examples on that, so I don't want to repeat that. But let me add what we need here then from an incentive schemes and regulation perspective. We need investments which are future-oriented into research institutes, into universities, but also helping companies and finally the grid operators really to work hand in hand. We need to take care that we are not cross-loading and shifting costs from one sector to the other so that we don't see what are really the most important future-oriented technologies forward. and we need to stimulate investments which come from both public and private sectors. The challenge is huge. We must have local play, as simple as possible, administrative procedures to stimulate that, and we need all the stakeholders really driving it forward. Otherwise, we cannot make this tremendous challenge, which is ahead of us. So the key word is we never need the one or the other. We always need the one and the other. And that is, I think, together with the flexibility keyword, really the key thought I want to leave. Let's leverage all potential, all technologies, all stakeholders which are there who can contribute. The challenge is huge, and otherwise we will not make it.
Thanks a lot, Gerard. You talked about investments in grids, I guess, but you ended up saying we need to talk to each other. We need all the solutions, and I totally agree with you. So my compliments that you sort of concluded in that way. Thanks a lot, Gerard. We will now hear from another perspective. We will hear from Mr. Rico Huttonen, who is working in the Ministry for Economic Affairs and Employment in Finland. And Rico, you happen to be my former colleague also. You've been a regulator. You were heading the electricity regulator before you had this job. So maybe you have different perspectives, but we heard a lot about how important rules and sort of the market design is. Can you give us something on that from your perspective? The floor is yours, Rico.
Tack så mycket. God eftermiddag. And hello, everybody. Yes, I'm glad to give you some further insights to the subject. To start with, we have this national target to become climate neutral by 2035, and for that we need, of course, much more clean energy to be integrated to our grids, and we need a lot to facilitate that. I will start by noting the rising clean energy demand. It's quite clear that if we decarbonize our industries, transport, heating, and all other sectors, we are going to need much more clean power. In Finland, for example, the estimation is that we have to raise power production by 50% by 2035. This means that we need an investment environment where various kinds of clean electricity production options are possible. My second point is about energy system integration, which we find a very important topic, and it's closely related to the issue of electrification. To create flexibility and to reduce emissions, we have to develop energy system integration solutions. Besides electrification, various energy conversions and other changes are needed, such that government policies have to facilitate. At the moment, we have just a new specific working group in Finland analyzing measures how to promote energy system integration. For us, far in the north, the specific challenge is to decarbonize the district heating sector, also by sector and system integration. And I find it also as a very important source of flexibility in the power system and the energy system in general. And related to that, my third bullet point is about demand side flexibility. We need many small and medium-sized customers, in addition to the industrial ones, to be flexible in the energy consumption. This trick will be possible due to digital, automated solutions, so-called smart energy solutions, as well as by improving energy services to customers. When customers have smart meters, standardized data, and economic motivation, I'm confident that our grid becomes much more flexible, integrating also intermittent electricity production quite nicely. To summarize, clean electricity is the key to climate neutrality, and promoting system integration is vital to really achieve our ambitious goals. Thank you, Dan.
Thanks a lot, Rico, and thank you for mentioning the district heating, the possibilities that is with the sector integration, also with district heating. I think sometimes we all think it's power to gas and that's it, but actually district heating is quite common in some places where maybe gas is not so prominent. So this is also very interesting. And of course, bringing together stakeholders. I think this is a theme I've heard from others, so thank you for highlighting that.
Thank you.
Yes. We will now move to yet another perspective. We are moving from Finland to Mrs. Vera Silva from GE Grid Solution. This is a company's perspective again, and please, Vera, the floor is yours.
Thank you very much, and thank you to the previous speakers who already highlighted several of the critical points, which I'll be building on and bringing more of a technology perspective. So indeed, flexibility is critical for large-scale integration of distributed energy resources. And as we say, large-scale integration, we're talking about millions and millions of new devices connecting to the system. So that requires scalability. That's been driven mostly by technology evolutions I'll be focusing on today. As we know, integrating a large share of variable generation is changing the way we operate the system and adding strain to system operators. We will need more ancillary services, different services, provided from resources which are connected to all layers of the grid. And we will have a lot more data being exchanged into the system. Therefore, we need smarter systems and we need advanced technology. So today, we're going from a grid that orchestrates hundreds of connected assets into a grid that will need to orchestrate millions of connected devices with large diversity of owners and systems that are operating this. So we're facing quite a challenge, and I'll take two examples of technologies helping to digitalize this grid and enable this change. First one, I can take the example of what we're doing in advanced automated systems, digital substations. Future intelligent substations, they will need to collect more data. They will need to communicate faster through optical fiber. They will have software platforms that will improve the operability and facilitate remote controllability, as well as they will be the first level of aggregation of distributed energy resources. They will play a key role to facilitate the management and orchestration of flexibilities. This comes in hand with the changes we have on the grid software that's deployed to help the system operators, the grid operators to manage the system, just as Liv, you mentioned before. And there will need to be, as I would say, all these systems that are today in the grid operators' rooms need to be DER enabled. So they will need to have a digital infrastructure that removes the data silos which we have today and that are currently obstructing an holistic network view. We have lack of grid visibility, often delayed response times that lead to network inefficiencies. And this is where the role of not only advanced grid software, as well as standards and interoperability will be critical to achieve basically the scalability we need to unlock this flexibility. Today, we had quite a lot of pilot projects that have been running around different parts of the globe that have proven the feasibility of these operations. But what we need now is to see how we can reach scalability and focus on removing the obstacles we have to scale up the system. We're looking today at just registering DERs. In California, we have one new PV site every 5 minutes. In Australia, 3,000 new PV sites every week. So we need standards for DER modeling, registration, provision, commissioning, as well as how we can control them so that they can provide services to support the system. We need to move from demonstrations that focus mainly on TSO-DSO interaction and make sure that we go all the way into reaching out for the flexibilities at the edge of the grid. And obviously, this requires also a transformation of the software systems we have in the grid operations and integrating distributed energy resource management all the way from planning the grid into the real-time operations. So to finish, what I would say is that to build a road ahead and integrate these distributed flexibilities and energy sources, we need a strong involvement of all stakeholders, from the regulation and standards associations to the grid operations, the consumers, but also the technology providers that will have to be designing these new solutions and bringing to the market the products that will actually enable the transformation and the scalability of the system. Thank you very much.
Thank you, Vera. Thank you for highlighting the important role of better utilizing what we already have in the networks and making it digital. I think that's very, very important in order to cope with what I think will be much more network capacity constraints in the future. And here flexibility can play a very important role as well. And you also end up saying that we need to talk to each other. We have been in silos. We need to bring stakeholders together. I think that's important. And that's also something I think regulators can contribute with. Thanks a lot, Vera, for your oops, sorry, I put myself on mute. That was a mistake. Sorry for that. Last but not least, I would like to hear from John Cho from NCORD in Korea. I hope John can give us the digitalization perspective, because I've understood that that is what you are working with every day. So please, John, the floor is yours.
Yeah, thank you, moderator. The innovation landscape for the renewable powered and artificial intelligence-based future, which maps the relevant innovation, should identify the synergized and formulate for the integrating high shares of variable renewable energy into power system and improve to allow the deployment of them for the resilience and the system flexibility. To solve these problems and issues, we need the new type of organization based on the energy transition, which connected power system and the market on real-time operation. So in Korea, that we have the several tracks for improving the new regulation and mitigating the traditional regulation. The public tracks by governmental agencies such as MOTI, the National Assembly and the National Energy Committee, private tracks by business, and the very special tracks like the sandbox for the testing of the emerging technologies. Especially these improving policies are being done at enabling technology, the new business model, the real-time power market design and the system operation for virtual power plant, peer-to-peer transaction, and non-metering, or the value of distributed energy resources, and so on. But in particular, we are mindful that the standards are made behind advanced technology. But in order to solve these problems, the various faster tracks are being operated to quickly make the recommendation to government agencies on system improvement. Among them, I would like to say that we should also consider and prepare the power quality problem due to the distributed energy resource. Due to the accelerated shift towards a carbon-free electrical energy system, the power system is changing in terms of both planning and operation with on the increasing integration of converter interface the renewable generation at all voltage levels. The connection of the RES to the power system is mostly achieved using power electronic converters. Equipment to interface through the power electronic converters can have both a positive or negative effect on power quality. depending on the type of the disturbance evaluated and the applied control strategy of the converters of solar, wind, and ESS. I think it should be widely accepted that the consequences of the deregulated power quality can have the severe financial implications, and many regulations or policies must be considered about this problem from the new perspective. Thank you.
Thanks a lot, John, and thank you for highlighting the frequency issues. I think flexibility can play an important role here as well. So we just have to get the act together. We have to utilize digitalization, and we have to use not put all the eggs in the same basket. And it's interesting that you mentioned also sandboxes. So thanks a lot. I think our time, unfortunately, is up. It went super fast. Very interesting perspectives. This fireside chat could have gone on and on and on. As I started to say, what we heard is utilize digitalization. There are some low-hanging fruits, I guess, in the network. Use different kind of flexibility resources. Not only one will do the trick. We need all of them. And we need to test, and we need to have platforms to talk to each other. Sandboxes is a good way also for regulators to understand what kind of regulation works. And I think some countries have already started to doing this. So this is very interesting. I think we will have a very interesting future, much more complex, but very, very interesting. So I'm looking forward to what will happen with the power sector in the coming years. And I got a very interesting question in the chat, because we always complain that people, younger people, or even normal consumers. We haven't talked about the consumers here in this part of the conference. Where should they engage? And I say engage, because this is the energy sector is the way towards the green future. So any organization for clean energy will do for young people. So I hope that you who posed that question have got an answer for me. Thank you from my side, and I guess over to the ceremony of the ISGAN Reward of Excellency.
Thank you, Anne, for moderating at best this very interesting fireside chat involving top-class readers around the world. It was quick, it was interesting, and very engaging. Thank you for making it possible. And now we move to the ISGAN Award Excellence Ceremony session. So I think we prepared a slide for this session, and I would like to mention that we are proud that since 2014, in partnership with the Global Smart Grid Federation, now Global Smart Energy Federation, ISGAN presented the ISGAN Award ceremony to recognize excellent smart grid projects, policy, and programs around the world. The ISGAN Award of Excellence seeks to leverage leadership and innovation in smart grids to accelerate the global exchange of best practices and to promote the replication or adaptation of proven concepts in order to make these results available and have an impact on markets, countries, and regions. The 2020 ISGAN Award of Excellence will mark 6th anniversary, recognize excellence in the field of smart grid with a special focus on digitalization, enabling consumer empowerment. There is a slide with the title of our theme for this year. Thank you. A wide range of smart grid project nominations were received, and the winning projects were selected by an independent international jury of smart grid experts, led by Mr. Reggie Pillai Kumar, that is chair of GSEF, who will also announce the next theme for the 7th ISGAN Award at the end of this ceremony. The jury selected the winning project based on the following 5 criteria: potential impact, innovation degree, consumer benefit and empowerment, economic rationale, and potential for replication. For this year ISGAN Award ceremony, we have a special guest, Director Koyama Masaomi from the Agency of Natural Resources and Energy, Ministry of Economic Trade and Industry, METI, in Japan, that will make the announcement of the winning projects. So I would like to ask Mr. Koyama-san to please take the floor. Thank you.
Thank you very much. Can you hear me?
Yes, very well.
Thank you very much for your kind introduction. And on the occasion of the ceremony of the 6th ISGAN award, I would give a short congratulatory remark. My name is Masabi Koyama, who is in charge of the international affairs on energy efficiency, renewables, and energy systems, Ministry of Economy, Trade and Industry, the government of Japan. First of all, I would like to express my sincere appreciation to Mr. Ray Kumar Pillai, the chair and the member of the 2020 ISGAN Award of Excellence jury for their work of the evaluation process. I also would like to thank to all the related staff of ISGAN, IEA, and CEM Secretariat for preparing this event under the difficult circumstances with COVID-19 outbreak. Small grid supports further expansion of renewables, stabilizing supply of electricity, and accelerating distributed energy systems. In this context, smart grids has become more and more important for energy transitions towards a decarbonized society. We have also recognized the importance of smart grid technologies that support resilient and clean energy systems under the global pandemic of COVID-19. As all of us are aware, the ISGAN initiative has been facilitating dynamic knowledge sharing, technical assistance, and other activities very actively since it launched. Especially, ISGAN Awards has been contributing to improve dynamic knowledge sharing among participants by sharing best practices and experiences through the selecting and awarding processes that focus on different themes each year. We believe it plays a significant role for the deployment of excellent smart grid technologies. The theme of this year is digitalization enabling consumer empowerment. The digitalization is essential for realizing smart grid, needless to say. And I would say excellent projects are selected as winning projects. I would like to congratulate 3 awards projects: Smart Grids and Smart Communities Demonstration Project by NIDO, Future Flow by ELES, and Digitalizing the Customer Experiences with Real-Time Control by London Hydro. I believe that those technologies must be spread and contribute to the improvement of electricity systems among participants. At the end of my remarks, I would strongly expect all the participants of ISGAN initiative to facilitate and contribute our activities for deployment of smart grid globally. Thank you very much.
Thank you very much, Koyama-san, for your words and your expectation about having this result replicated and used broadly. So the ISGAN Award winner of this year is the Smart Grid and Smart Community Demonstration Project. It's led by Japan and NATO in Japan. So congratulations also from my side. Unfortunately, Mr. Kazuo Yokota cannot be with us today, but he provided us with a video that will be played shortly. So I'd like to ask IT personnel to please launch the video that has been recorded by Yokota-san.
Ladies and gentlemen, good evening. My name is Yokota, Director General of NEDO. NEDO is one of Japan's largest research and development management organization. I am truly grateful for being given this opportunity to speak today. We are truly honored and proud to receive the winner at the 2020 ISGAN Award of Excellence. In this project, aiming to solve energy issues and expand introduction of renewable energy in Slovenia, we have worked closely together with the Slovenian government, LS and Hitachi, and we believe the hard work and dedicated dedication of our entire team has led to this achievement. We'd like to share this honor with all of the project members. This is the system overview. Integrating Hitachi's advanced ICT with Slovenia's existing distribution infrastructure, we have built a smart grid which enables us to maintain and improve the quality of power supply and at the same time generates economic benefits for both consumers and system operators. In addition to LS, a number of Slovenian companies, local governments, and relevant institutions have joined this project. Now, I'd like to introduce some of our main achievements and expected future benefits briefly. First, through their function. Electricity consumption of household dropped by 3% on average. At the same time, the power network tariffs reduced by 5% and the profit was given back to the consumers. Second, through optimal control of grid voltage. Hosting capacity of the power grid for renewable energy increased by over 50%. And finally, I'd like to talk about 5 megawatt battery energy storage system we are installing. They are expected to prevent voltage dips damages and achieve islanding operation and tertiary control reserve. Verifying such value-added services, we now aim to establish a business model in the future. Applying the most advanced technology, this project has presented the possibility that not only grid operators, but also all the consumers connected to the grid could be benefited and create a win-win situation between them. Now, I'd like to conclude my speech. Thank you very much for your attention.
Hope you enjoy the video. Unfortunately, I'm not connected to YouTube, so I couldn't see it live. I saw it previously. And now we move it to the runner-up winner. So if you put the slide, please. We have the winner is the Future Flow project that is led by Slovenian TSO, LS. And we are very glad to have with us Mr. Uroš Salobir, that is Director for Strategic Innovation at LS, the Slovenian TSO, and a very well-known expert and person within ENTSO-E, the European Network of Transmission System Operator, that will receive the award and will also show some highlights from the Future Flow project. Uroš, the floor is yours. Please try to remain within the 3 minutes. I know you have many interesting things to show, but the time is very limited. Thank you.
Thank you, Luciano. I hope you hear me well.
Very well. Yeah.
Okay.
Thank you.
So yes, we are so happy that from such a small country as Slovenia is in the heart of Europe, we could come up with such great projects and get so much recognition on the world stage. So thanks to everyone who was involved in this, and also a warm welcome to all the participants of this event. Now, the Future Flow project as such, we have prepared a short presentation, if we can show it, is something of a very tough collaborative work of TSOs, of business-oriented entities, and we really managed to break some barriers in traditional way of doing demonstration and research projects. So in this case, we actually gathered 4 transmission system operators, and we actually managed to do a cross-border demonstrations to show that the future of the market is really something what we should provide for the users, and that these services are something of the benefit for everyone. So if we can go on with the next slide, ILES is transmission system company, and we have a very strong presence in the region. Slovenia is also neighboring to many important production centers and consumption centers. So this is also the reason why we are so internationally motivated. So if we go to the next slide, the main point of all this project is, of course, that EU is really strongly committed to climate neutrality by 2050. And we can only understand this if I go to the next slide, that we really see the picture of these huge changes will be necessary to bring these things in life. And this is driving the need for changes. And now if you go to the next slide, these changes will come from two sides. The first will be traditional physical assets, and the second will be more of smart assets, energy efficiency, activation of consumers, and smart grid. So if you go to the next slide, the situation of today is that we have some kind of transitory state. We don't know exactly what's going on. The coal production plants are going down. The ancillary services market are not really performing well. So what will come up at the end is that everything what is coal will slowly disappear, and we will need new services, and we will need either conventional storage, we will need gas, or we will need solutions like future flow. Please go to the next slide. So here we are actually showing some of the largest findings coming out from the future flow project. The first is that the challenge of the energy transition can actually be met by distributed resources of flexibility. The second finding, the next slide, shows that these platforms should be integrated across as large areas as possible. If we don't manage to put them together, the distributed sources will not work for us. If we go to the next slide, I'm showing the third of four main conclusions. So one back, please. So yeah, we're very fast now. So the centralization of these platforms is also a critical discussion. So we cannot simply believe that everything will be unified, that we just establish one platform and then everything works. So future flow shows that we have to have this democracy of platforms, and only such platforms can play in the future markets.
Uros, you were very fast, but we are late with the program. Can you say a few words, a key word about your project, and then we definitely will go through the detail. A few words about the project, apart from being with us.
So, I'm finishing. So the conclusion number 4 is that we actually need to understand these new technologies, and that we should all share this knowledge so that we can all derive this future in the best possible way. That was my conclusion, actually. Yeah.
Thank you very much. It's a very nice project. We didn't want to cut your presentation, of course. Now we have to move fast because already 4 o'clock. I would like to ask Dr. Regi Pillai to say a few words about the next theme for the next year ISGAN Award. And also I would like to thank him for the strong collaboration and leadership of GSGEF. Thank you, Regi. Please.
Thank you, Luciano. Good morning, good afternoon, good evening to all the participants. It's my pleasure and privilege to address this forum. And we have been very fortunate and privileged to be associated with the ISGAN for the last, right from inception. And last jury, and last 3 awards I had the honor of jury.
Unfortunately, Regis, your connection is not perfect.
On the same day in
Dr. Regi? Maybe the problem is on my end, but I don't.
Yeah, can you hear me now?
I can hear you now. Please say.
People can hear me?
Yes, I think so. Oh, now okay. The line
sorry
is
about
better.
That. I said, ask me.
I think we have a bad connection from Dr. Regi's side. Fully engaged in the ISGAN Award, and not only as a president and chair of the jury. I'm afraid his connection is not the level we need. Maybe maybe we will hear back from him. But I want to again to emphasize the importance of really seeking for projects that make a step toward the energy system transition. So thank you so much for your attention. We are very glad taking your time for this kind of award ceremony, and we will let you know when the new topic will be available for submitting new application, new project. I think I can close this session now and give back the floor to Mr. Sadamori-san from IEA, Director, for introducing to the closing remarks. Thank you very much for your time and your attention to this event.
Thank you, Mr. Martini, for this very difficult task of the time management with this very rich content of the program, and congratulations for the award winners. So now let me turn to the final concluding remarks, and I would like to invite Director General Mr. Gilberto Dialuce from the Italy's Ministry of Economic Development. So Mr. Dialuce, good afternoon, floor is yours.
Hello to everybody. First of all, let me thank the organizer of this interesting event and the speakers who have presented the state of the art of the energy sector integration. A particular thanks also goes to the Honorable Chilean Minister of Energy, Mr. Juan Carlos Rubé, and the Saudi Arabia to also CEM 11. On behalf of our Minister of Economic Development, let me wish also to the entire PEVENS CEM program the best success to deliver its noble target toward the decarbonization of our energy system. Let me conclude with just some final remarks. We are experiencing an unpredictable times, which impose to us a deep change of our habits and lifestyle. The uncertainties we face make the challenge to find a viable hardware to a possible solution toward the new growth path, guaranteeing sustainable, affordable, and secure energy for all. Power system flexibility and ISGAN works you presented today seem to pursue the mentioned objective, and their efforts are really invaluable during this particular period. This workshop has clearly shown the importance of joining forces and to have a coordinated approach, especially when addressing complex challenges associated with the ongoing energy system transformation that require different expertise and active engagement of many stakeholders. Without no doubt, electrification is a pillar on the ongoing energy transition and the path we do not need to follow in every sector where it could be implemented, such as mobility. However, successful integration of EVs in the power system comes with challenges requiring a diverse array of technological solutions, infrastructure planning, closer collaboration among stakeholders, and action from policymakers, business, and technology developers, system operators, and EVs owners. In Italy, we are launching a series of investments in order to stimulate the market to adopt further orientation towards the electric vehicle integration in power system, as we include in our National Energy and Climate Plan to 2030. Investment in this kind of vehicles in Italy are expected to be particularly effective in 5-7 years, with almost 6 million electric powered vehicles in overall circulation by 2030. Approximately 4 million out of which will be all electric. The CEM Horizontal Accelerator is a concerted effort of 4 CEM work streams able to produce a multidisciplinary approach to EVs, which offers new insights into power system integration and sector coupling, guiding development of modern integrated energy system of the future. We are strongly committed to international cooperation, and particularly to Mission Innovation Challenge 1 on smart grids, of which Italy has the co-leadership together with India and China, and to ISGAN, of which Italy has the presidency. We believe CARE international program is an important way to develop faster and better complex challenges. Italy will continue to support and be part of international cooperation that will help us to face the challenges in the next years, characterized by a strong increase of energy demand and the complexity to manage networks. We are strongly committed also to support the future activity of CEM to develop a more competitive and sustainable energy system. It is a global priority to succeed it in order to guarantee a bright future for all. Our feeling is to demonstrate that international cooperation is also able to produce some action to help fragile territory to get out of energy shortage. And it is a privilege for me to announce a future project in collaboration with the IEA to help some communities less lucky. We consider this ambitious project as a fruit of international cooperation. For sure, an holistic approach, as the title of this event, is a viable solution, combining the interaction between structures and the deep knowledge of our researchers and scientists working to solve problems, apparently with no solution, as shown by the past experience. Finally, let me express my sincere gratitude to all participants and the panelists, and let me congratulate you for all the important initial achievements, and I wish you a successful future for your activity. Thanks.
Thank you, Dr. Dialuce. This was the final remarks from your side. Thank you very much for closing our event at best. We talk about flexibility for 1 hour and a half, and I have a proposal for showing some flexibility. Dr. Reggie Line is now back. He is asking for just 1 minute to announce the new theme for the ISGAN Award of next year. If I'm allowed to give him the floor, I will be glad. Dr. Reggie, are you back? Oh, bad connection again. So, even if we provide flexibility, it seems you will have to discover yourself, which is the next theme for ISGAN Award. And I would like to thank everybody, all the participants, and also the speakers, and everyone that contributed to this event, and Enrique that spent a lot of effort on this organization of this detail, and the Saudi Arabia IT team that support us at best. I have nothing to add. Thank you for your time, and please join the next pre-event of CEM 11 that is very important and very interesting. Thank you very much from my side.